Good morning, good morning, good morning. A very good morning. I'm still working on the same paper. But now I have moved on to another fluvial landform. Which is your waterfall. Today I'm in love with fluvial landforms. Okay. Waterfall. Of course, that's a waterfall. You can see there are two landforms or two diagrams that are shown there. So the first thing that you have to familiarize yourself is you look at the two diagrams. Which one is the before, which one is the after? So you have got this one as the before, you have got a resistant rock, and you have got a less resistant rock. What is it that is happening? What is happening is obviously erosion here is happening at a slower speed because this is a resistant rock. Here is happening at a faster speed because it's a less resistant rock. Obviously, we are saying now we have got resistant and less resistant rock. So this one is eroded faster. As you can see, it's eroded faster. So over time, what will happen is we'll have an overhang, which is this one. And because it does not have any support, what will happen? It will gradually collapse into the plunge pool. This is your plunge pool. That's why you see these boulders. Why? Because this one does not have any support, so it's going to retreat backwards, which is a form of headward erosion as well. It's retreating backwards. The moment it has eroded more of this soft rock, which means the resistant rock has nothing to support it, then it falls into the plunge pool. Then it also retreats upstream. It's retreating upstream, which is a form of headward erosion. That is backward erosion. Okay. Then the question reads, waterfall is a base level of erosion. Obviously, when you talk about something that is temporary, we are saying that with time it will eventually be eroded. That's what has happened here. You understand? It's a neck point. It's not permanent. It's temporary. That's why we say it's a temporary base level, because it's there, but it is bound to be removed. That's what we mean when we talk about temporary. But when we talk about permanent, we are talking about the sea level. It will remain the way it is. But here, it's going to be removed. Why? Because you can see it's cutting back to its source through headward, backward erosion. That's why we end up now at B. We see is it retreating upstream. That's what makes it temporary. So the question there is temporary base level. Okay. Identify the type of rock at Y and Z respectively. So Y is your resistant rock. That's why it takes time to erode as compared to Z. So Y is resistant rock. Then this is what? This is hard rock or resistant rock, whichever way you call it. Hard rock. This is what? Soft rock. You can call this one resistant rock. Okay. Resistant rock. You can call this one less resistant rock. Okay, whichever way you call it. Okay, that's basically what this is all about. So you've got your marks there. Then, except for waterfalls, name one other fluvial landform caused by erosion, except for waterfalls, which means you cannot give waterfalls as an example. Name one other fluvial landform caused by erosion. Obviously, you are talking about your rapids. That's another one. You are talking about your of course, you're talking about your meanders as well. Meanders are caused by lateral erosion. You talk about meanders as well. Meanders, they are caused by lateral erosion. Okay, it's a form of erosion. Lateral erosion. Meanders. You can actually talk about, of course, Oxford Lakes. Of course, where we have got Oxford Lakes, of course, there is actually erosion that is taking place because it's a remnant from the meanders. Okay. You can also talk about the terraces. Of course, think about what happens during rejuvenation. The terraces that you find on a valley. What happens during rejuvenation? What happens during rejuvenation? What happens during rejuvenation? What happens during rejuvenation? Okay, what happens during rejuvenation? We have got our river now. It starts off here, but as the river has got more energy, starts what? Actually erode downwardly, which means now we have got different terraces that forms. Now this is where our valley is, so it's also a feature of erosion that actually takes place. So we have got rapids. We can talk about potholes as well. There's a lot that we can talk about. Okay, we only need one. In which course of the river are waterfalls mostly found? We are saying now, when you look at the profile of a river, we have got the upper, middle, and the lower course. Oh, how I love this. Okay, middle and lower course. So we have got our waterfall in the upper course of the river, because that's where there is more erosion. That's where the river is more erosive. That's where the river has got more power. Okay, more energy, high velocity, which results in more vertical erosion. So we have got we have got the waterfall in the upper course. We have got it in the upper course. Okay, we have got it in the upper course of the river. Then state the dominant fluvial landforms in this course of the river. What are the dominant fluvial process, not landform? Dominant fluvial processes. What are the dominant fluvial processes in the in this course of the river? Of course, we've got vertical or downward erosion. What we have got vertical or downward erosion. This is the dominant fluvial process, vertical or downward erosion. Explain how erosion in sketch B caused the waterfall to move upstream. How erosion, okay, we are talking about, if you look at this, you can see that it's cutting back to its source. This is edward erosion. How has this taken place in B? That is, explain how erosion in sketch B, a waterfall moves upstream. Of course, this is edward erosion. So the softer rock, as you can see, the softer rock here, this is the softer rock. The softer rock is eroded, leaving the hard rock. The softer rock is eroded, leaving the harder rock. You see, you can see here, all right? Erosion undercut the less resistant softer rocks. This is undercut the less resistant and softer rock. Then you've got erosion undercutting will create a plunge pool. This is your plunge pool. Okay, the resistant rock is not supported by the soft rock. This one now is no longer supported by the softer rock. Why? Because it has been eroded, because it's a softer rock. Okay, and this creates an overhang. This is our overhang here, which does not have any support. So the overhang resistant rock, which is this one, will eventually collapse. Overhang resistant rock will collapse into the plunge pool. This is what has happened there. This is what has happened there. So this is how it actually happened. Can I say it again? Okay. How this has happened. Okay, we are saying now the softer rock, okay, that is Z, okay, is eroded, leaving the hard rock. So which means this one is eroded, leaving the hard rock, which is Y. Okay, then erosion undercutting less resistant rock occurs, which means this is the less resistant rock. There is erosion that is taking place. There is erosion that is taking place. Erosion that is taking place upstream. Okay, then undercutting will create a plunge pool. This is a plunge pool that is happening there where you've got a soft rock. The resistant rock is not supported by the soft rock. Now this is no longer supported by the soft rock, but it has been rotted backwards upstream, and this leaves an overhang which will eventually collapse into the plunge pool because there's no support. That's what we are talking about. Explain how waterfalls impact river grading. How do they impact river grading? Of course, the presence of a waterfall on a river profile or on a river profile, it shows that it's ungraded. Okay, so explain how waterfalls impact. What is the impact of waterfalls on the river grading? Where we have waterfalls, it shows you that the river profile is ungraded. Okay, waterfalls create nick points. That's what happened. The waterfalls, they create nick points. Waterfalls create nick points, which are abrupt changes in the river gradient and profile. So we are saying now, assuming that this is our profile, where we have got waterfall, of course, we are saying that it maintains an ungraded profile. There is nick points. Okay, assuming that this is our waterfall, it creates nick points, which means the river becomes ungraded. Okay, nick points can lead to increased erosion, which means where we have got nick points, there's more increased erosion, which means the river is now becoming rejuvenated. It has got more power, it becomes more erosive. Okay, gorges and terraces altering the river's overall slope, and it passes towards a more graded profile, which means it becomes ungraded. That's basically what we are talking about. Waterfalls create nick points, which are abrupt changes in them. River's gradient profile. Nick points can lead to increased erosion and formation of features like gorges and terraces, changing the river's overall slope, its path towards a more graded profile, which means now even if it was graded, it becomes ungraded. That's basically what we are talking about. So this is it in as far as waterfall is concerned. Thank you.